I was almost tempted to start this question with singing I've Got the Power, but I'm not going to. Power. It's one of the most misquoted words, I think, in science. Where you've got a class of enthusiastic but slightly dim students, and you ask a question, and that kid who puts their hand up immediately before engaging brain, who hasn't got a clue, will often resort to one of two words. One of those is pressure, one of those is power. And then you ask them, and they look at you blank, and they haven't got a clue. But God bless them, at least they've had a go. So, by the end of this lesson, you will know what power is. Let's take a cell, a battery. Inside it is energy. You'll be thinking, yes, Mr. White, it's chemical energy. Chemical energy. And if I was to plug that into a light bulb, you hopefully will have no issue in knowing that the electrons are going to carry that energy. Let's see if I can grab that. Carry that energy, blah, 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 from the cell, drop it off to the light bulb, and the light bulb's going to turn it into electrical energy, or light energy, and off it goes. Loads of heat, and it's going to carry it away. So we can work out, when we talk about power, we're asking ourselves, how much energy every second? So power is how much energy transferred per second. So that's the definition of energy. It means of power. Come on, sort yourself out. Power is how much energy transferred per second. And if you think about it, inherent in that description is pretty much the equation. Energy, second, and so three things, power, energy, and second. And then if I highlight these, is and per, well, they're mathematical. Is means equals, per means divide. So written in this sentence is actually the equation. Power, I'll come to the unit in a minute, is energy per time. Now, the units are joules for energy, seconds for time, and power, because a guy called James Watt figured it out, he got to put his name on the end. So we measure it in watts, and usually we just write it as a capital W. So watts, like that. So when I meet you in the future and I'm doing power again, reminding you, I may use that old joke. What is the unit of power? At which point most of the class say, I don't know. And you say, no, what is the unit of power? And at that point, one child actually did cry at me. I kept saying it. She thought I'd lost my marbles. But in fact, you're stating the unit in the question. What is the unit of power? It's funny if you're a teacher. You don't have to laugh. So there's our equation. If you can get that copied in, that description above as well. I found a new colour. This is lovely. So that's my second new favourite colour. My newest favourite colour is this turquoise. So that's our equation. As always, boop, 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 goes in a nice little triangle. We have power at the bottom, don't get caught out putting it at the top, is energy over time. So we can rearrange that, cover up the one you want, say what you see. So if we want to know the energy of something, we cover up the energy, and we can say energy is power times time. Or we could, if we're feeling so inclined, we could find the time it takes to spend that energy if we know the power. So again, we cover up the time and we get energy divided by power. So let's have a look at it in action. Let's do three examples. Example 1, example 2, example 3, because we're near the end. Let's find the power for that one. Let's find the time for that one. And let's find the energy for this one. So let's take the first one. Find the power. So we might take something like somebody climbing the stairs. Let's do that. I had to think for a second. I am so rusty. We might have somebody who's going to climb those stairs. Oh my gosh. I'm not doing art ever. There we go. They're very short as well. Could be me. And they're going up the stairs. So to get from the bottom of the stairs to the top of the stairs, we could actually work this out. Is there an equation that links mass of the person, the height of the stairs, and gravity that pulls them down? And I can all hear you thinking, yeah, GPE. So we could work it out. We could find the GPE of this person. So let's do 2 for 1. Let's say they've got a mass of 50 kilograms, average person. I'm currently 80, too much coronavirus eating. And gravity, let's just keep it simple. Let's call it 10. And the height of the steps, let's say altogether 1.5 meters. Let's work out the GPE first, so the energy they've got. So we'll do M, 50, times gravity, 10, times 1.5. Let's give it a go. So we got 50 times 10 is 500, times 1.5 is 750. 750 joules of GPE when this little fella has got to the top of the stairs. Beep, beep, beep. 750 joules. Now, that's the energy part done. The other thing we need to know is we need to know the time. How long did it take him? So let's say it took 10 seconds, because that's easy to do in my head. So 10 seconds to get from the bottom to the top. So we can find the power quite easily. I'm just going to shrink everything so it fits. We'll start to go into question 2. I'm going to cheat a little bit. Shrink it down. Pretend I'm neat. There we go. So let's have a look. So the power in watts, because watt is the energy, what is the unit of power, is 750 joules divided by 10 seconds, and we get 75 watts. So now let's find the time. Let's keep that 75 and ask ourselves, what if the same person had to get up a flight of stairs that was 10 meters? We can work it out. We can use MGH again. Not changed mass. We're assuming he's lost none of his body. Up he goes. Foot there, arm there, arm there. And let's find the new energy first. So we'll do MGH. Mass of 50. Gravity of 10. Height of 10. 5,000 joules. And he was using, or she, so that was the energy. The power was 75 watts. Again, I'm going to shrink this down so I don't roll into question 3. Let's put it there. So we know the energy and we know the power. Now we need to find the time, because we don't know it. So we're going to use a triangle. Just to be sure, even I use them, just to be certain that I've not messed up, because it happens now and again. So I take my triangle. Remember, power is energy over time. Cover up the time. Beep, 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 beep. So I'm going to do energy divided by power. So let's give it a go. Let's get rid of that. So we're going to do energy over power equals time. That's 5,000 divided by 75. I have a feeling that should be easy. I want to say 20. No, I don't know. I'm going to work it out on a calculator. 5,000 divided by 20 equals 250. I was going to say 25. So I was kind of there. 250 seconds. And there we go. The time to get up the stairs. And the last one. What if now, same person going up the stairs, huge stairs. Want to find out how long. They decide to go from the bottom of the stairs to the top of the stairs, and the total energy this time is 7,500 joules. They're running up them, same power, 75 watts. So power, 75 watts. What is... Oh no, it's not the energy. Don't need that because I'm trying to find that out. They're going up the stairs and they do it in a total time of 1 minute. I've put a trap in here. So at this point my iPad has broken. So I'm just going to reboot that. Should put me back where I started. There we go. So let's find out. We know the power. We know the time. Let's find out the energy. Back to that triangle. Can't recommend them enough. No matter how smart you are, it's always nice to know you're definitely going to be correct. So power, energy over time. Cover up the one you want. I want energy. So they're next to each other, which means you multiply them. So I do energy equals power times time. I put the power in, 75. I put the time in, 60 seconds. 60 seconds, don't get caught out. And you do that, and I don't know what the answer is, so I'm going to cheat again, use a calculator. So we have 75 watts times 60 seconds gives us 4,500 joules. 4,500 joules. And that's the energy that person spent moving up the steps. As always, take a photograph, put a Google Doc in, click that hand in button so I can keep a track. Any problems at all, you get hold of me, write to your teacher, me or Miss Bennett, and take care. Any problems, let me know. Bye.